This is physical geography form 3, and we begin with lithosphere. So the word lithosphere refers to solid outermost shell or part of the earth. So to understand about lithosphere, it is important to look at the internal structure of the earth. So internal structure of the earth. In Form 2, you were introduced to some concepts of internal structure of the earth. And the internal structure of the earth, we may dwell much on emphasizing the information of earthquake waves, lava emitted from volcanoes, crustal borings, and deep mine operations. So from the studies, it has been discovered that the Earth is composed of three main concentric parts or layers. These layers are the crust. So the crust is what we call lithosphere, and the mantle is also known as mesosphere, and the core is also known as barosphere. So this is the diagram that we see. Everyone may pay attention. So the internal structure of the Earth. For example, at the center of the Earth, we have inner core, which is solid. So we have it has solid iron. The temperature is about 4,300 degrees Celsius. So it covers a distance of about 5,200 kilometers. And after the inner core, we have this outer core. This is outer core, the yellow part. From there, we have the mantle here. So in the mantle, we find some minerals like magnesium, aluminium, iron, silicon, and we also have the other elements which are not mentioned here, but it is plastic in nature. Plastic in nature. So, and we have this, the outermost part that we as people sit on. So this is the crust. So the crust may include the rocks, all the rocks we see, and the soil we sit on. So if we come here, it's also another diagram which actually trying to depict uh, the parts of the internal structure of the earth. So here, the black part, it's inner core, and this other part is the outer core. And if we see here, this is the mesosphere as mantle. So the lithosphere or the crust is what we see here. What we see here. So I ask all of you to pay much attention to this. So internal structure of the earth is covered by the atmosphere. So you can understand that the atmosphere is composed of mixture of gases, which is just above the Earth's surface. So let us look one by one. So for us to understand the crust is the outermost layer of the lithosphere. For example, let me give you an example of an orange. The cover of an orange is like the crust, and what we eat inside is like the mantle. And the orange has got the center. That center should be taken as the core. So it's the same as a mango. So a mango, the cover that we peel off, we take that as the crust. And what we eat, we should take that one as the mantle. And that seed that we throw away, we should take that one as um, the, 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 the core, the core. So it is important to know that the crust is a layer made up of two parts. So the continental part, so the part that we live, and the part that we have mountains, the soil. So it is known as seal. So this means silica and the aluminium. And the oceanic crust. So here we look at the base of the ocean. It is collectively making this acronym SIMA, which is silicate magnesium. So the continental crust, this is the upper part of the crust which forms the continents that we see. So if I go here, so you see there is Africa here, and there is a we have Africa, we have India. So these are like continents. So the continental part forms the continent. So it is made up of granite, so rocks. These rocks are rich in silica and aluminium. That's why we call it seal. Seal. So the granite rocks are lighter, and they have a density of 2.7 gram per cubic centimeter. So from there, let's come to the oceanic crust. We say we have two parts of the crust. So we have two parts of the crust as oceanic and the continentals. Now, oceanic is found at the lower part of the crust. It is mostly filled with water. So inside at the bottom of the ocean, that's where we find this oceanic crust. So it is made up of some types of rocks known as basaltic rocks, which are rich in silica, iron, and magnesium. So the part has a lot of silica and magnesium. Therefore, we call it sema. It has heavier rocks, for example, with a density of 3.0 gram per cubic centimeters. Now, the floating continent crust on the oceanic crust. We should also understand that the continent is floating on the crust. So, since granite rocks that make up the continental crust are lighter, with an average density of what we have seen, and also the oceanic crust with heavier rocks, continental crust appear to be floating on the oceanic crust. So, for example, we look at this diagram here. So this is the continent, and this is the oceanic part. So it's like continent is sitting on the oceanic part. So what are the differences between oceanic crust and the continental crust? So in terms of thickness, it means continental crust is much thicker as compared to oceanic crust. And in terms of age of the rocks, continental has a very old rocks as compared to oceanic, which has a very young rocks. In terms of weight, oceanic are lighter, and oceanic are heavier, whilst the continental rather are lighter. So, in terms of name of the rocks, continental crust contains contains granite rocks, while oceanic crust has basaltic rocks. Uh, in terms of the uh, in terms of the type of mineral that we get in these rocks, so in the continental crust we have um, silica and alumina. Whilst in oceanic crust we have silica, magnesium, and a small amount of iron. Now we have this boundary, the boundary between the crust and the mantle. We call it more Moho discontinuity. Moho discontinuity. Moho discontinuity. That's the boundary that separates the mantle from the crust. Now let's come to the mantle. The mantle is further divided into two, upper mantle and lower mantle. So in general, let's look at the characteristics of the mantle. So mantle, the layer that is between the crust and the core. The layer that is between the crust and it has a thickness of about 2,900 kilometers thick. So mantle is both solid and liquid, but the greater part of mantle is semi-molten. It is semi-molten. So the semi-molten rocks that make up the mantle is known as magma. So magma means molten rock. So in the mantle, there are convective movement that take place. There are convective movement that are taking place. So the layer is denser than the crust. That is why it is under the crust. It is under crust. Now between the mantle and the core, there is another boundary that we call Goldenberg discontinuity. Gutenberg discontinuity. This is the boundary between the mantle and the core. And the core is categorized into two. We have inner core and outer core. So innermost layer and is divided into two, the outer core and inner core. Characteristics. So you see that the core is made up of solid rocks with metallic properties. So its temperatures are very extreme. That we have to know. The temperatures are very extreme. It has two main rocks that make up the core, which is nickel and iron. So because of the nickel and iron, we call it like knife, nife or nife. So it is subjected to very high temperatures and it has extreme pressure. So characteristics of core is that it has high temperatures, it is subjected to extreme pressure. Um, you can also see that the core has also the largest radius of about 3,480 kilometers. So it is also the source of gravitational force. So it is known to be the source of gravitational force. That is what we know as of now. So we can still appreciate all this. Now let's come to increase of temperature in the internal structure of the Earth. Increase of temperature. So temperature increases with depth in the internal structure of the Earth. So as we go deeper into the Earth, the temperature is rising. The temperature is rising. What are the reasons why temperature is increasing as we go down? So internal parts of the Earth are cooled at a slower rate than the outside part. And radioactivity decay. We have also radioactivity decay that release heat from the inside the earth. Therefore, it must have high temperature. So the weight of overlaying materials exerts pressure on the core, resulting into high. So you see the mantle, the crust is sitting on the core. So therefore, the core is subjected to a lot of pressure. This increases its temperature. Now, let's come to the importance of internal structure of the earth. So, internal structure of the earth is very important. Why? Because it is the home of variable minerals. For example, copper, gold, iron, nickel, which people put them into their productive uses. So, source of variable minerals. Number two, uh, the internal structure of the earth has helps us to understand the occurrence of some geological processes such as volcanic eruptions. For us to understand the volcanic eruptions, earthquakes, folding and faulting, we depend so much on the internal structure of the earth. And it helps to understand the idea of drifting of continents. So we talk about the continental drift theory and the plate tectonics. For us to understand these two things, we need to study internal structure of the earth. So simply put, importance of internal structure of the earth: number one, home of valuable minerals or source of minerals. Number two, it helps us to understand some geological processes, for example, volcanic eruptions. It also helps us to understand why continents have drifted apart to the current positions. And it is also a source of gravitational force. So we have some questions that you have to respond. So everyone should answer these questions. Number one, of what importance is the mantle to the crust? Of what importance is the mantle to the crust? Number two, mention any three characteristics of the mantle. Number three, why is the innermost layer of internal structure of the earth regarded as a knife or a nife? Draw the internal structure of the earth and show three main layers. Moho discontinuity and Gutenberg discontinuity should also be there. Explain the importance of Mohorovic Mohorovic discontinuity in the internal structure of the earth. So this is the first part that we have covered. We have covered the first part, which is very important to set a pace for us to understand the other part that comes that comes um, afterwards. So thank you very much for this part. We appreciate so much.